Hello class, this is going to be our flipped classroom on periodic table of elements, the different types of elements and their properties. As always, feel free to pause this video at any time to take notes. Now, we are going to talk about the different categories of the periodic table of elements. So I'm showing you here the periodic table. There are 118 elements total, but I want to talk about their specific categories. So I'm going to break them into 4 parts. Hold on, let me zoom in here. They are metals, nonmetals, metalloids, and noble gases. Those are the 4 types of elements. So first let's talk about where they are located. So on the periodic table, if you look carefully, you'll see this zigzag line going down right there. You see that dark line? That is the separation between metals and nonmetals. The metals are to the left of that staircase. So everything here is a metal, including these ones down here, which means most of the periodic table, I'd say about 80% of it, are metals. The only exception is this guy right here. Hydrogen seems to be in the wrong place. It is the only non-metal that's on the left-hand side. Everything else is a metal. So then where are the nonmetals? They're on the other side of the staircase. These guys right here are all nonmetals, including our friend hydrogen. Next are metalloids. Now what are metalloids? Well, they are things that are kind of part metal, part nonmetal. They have properties of both. So the metalloids are the ones that are physically on the staircase. So the general rule of thumb is this. If there is an element that's touching 2 lines, 2 of these black lines, then it is a metalloid. So as you can see, boron, letter B, is touching 2 lines. That is a metalloid. So is silicon. So is germanium. So is arsenic, antimony, and tellurium. So these 6 elements, B, Si, Ge, As, Sb, and Te, are metalloids. Now you might also notice that there are 2 other elements that seem to also be touching 2 dark lines. There is Al, which is aluminum. You can see it's touching those 2 lines. And Po, which is touching 2 lines. Those are exceptions. Those are not metalloids. They are considered just metals because they have only metallic properties. So aluminum and polonium are metals. They're on this side. Everything else that I pointed to, those are metalloids. Okay, and then finally we have noble gases, and the noble gases are simply in the last group of the periodic table. They're group 18. All of these guys here, helium, neon, argon, krypton, xenon, radon, and this new one, number 118, which doesn't have an official name yet, those are all considered noble gases. So those are the parts of the periodic table, and those are where they're located. Now let's talk about their properties. So first let's talk about metals. What physical properties do metals have? Well, as you can see by my list here, they're shiny, which means they have a luster. You already knew this. When you think about metals, you think about things that have sort of a metallic sheen to them. They're also malleable. That's a fancy word that means they're bendable. If you try to bend a metal, it will bend if you're strong enough. Ductile, which means you can hammer them into sheets and stretch them into wire. They generally have very high melting points. As a matter of fact, most of them are solids at room temperature. And of course, they are conductive. They conduct both heat and electricity, which is why we make pots and pans out of metal, which is why we make wire out of metal. Now, the only exception to the solids at room temperature rule is mercury, the symbol Hg. It is the only metal that is a liquid at room temperature. So I'm going to show you where that is on the table. Right here, mercury, number 80, is the only metal liquid. The entire thing here are all solids except for this guy right here. The only metal liquid. So next we have nonmetal physical properties. So as you might imagine, they're exactly the opposite. Nonmetals are dull. They're not shiny. You try to bend a nonmetal, no luck there. It's just going to break. They're brittle. Generally speaking, they have low melting points. As a matter of fact, some of them are even liquids or gases at room temperature, so we'll say they have low boiling points. And they're certainly non-conductive. Unlike the metals, though, the nonmetals can come in any phase of matter at room temperature. However, just like the metals, there is only one liquid nonmetal at room temperature, and that is the element bromine, symbol Br. I'll show you where it is. Right there, element number 35 is the only liquid nonmetal. So on the entire list of 118 elements of the periodic table, there are only two elements that are liquids at room temperature: the metal mercury and the nonmetal bromine. Everything else is either a solid or a gas. Now, as a side note, I'd like to point out that if you look at group 17, it is the only group on the periodic table that contains all three phases of matter. So right here, group number 17, fluorine and chlorine are gases at room temperature. As we already stated earlier, bromine is a liquid at room temperature. And then iodine and acetylene are solids at room temperature. So that one group contains all three phases of matter. Okay, next we're going to talk about metalloid properties, and this is going to be very simple. I'm just going to state that metalloids have properties of both metals and nonmetals. They're a mix. Some metalloids are conductive, but they're brittle. Some have high melting points, but they're dull. And as far as noble gases, their physical property is that, just like it says in their name, they are all gases at room temperature. And again, the noble gases are group 18. Last thing we're going to talk about today are the chemical properties of these elements. So chemical, remember, means that how they react. You can't have a chemical property unless you're describing something changing into something else. So what are the chemical properties of metals? Well, simple. They react with nonmetals. And the further down and to the left you go, the more reactive the metals are. So for example, if I'm looking at this table and here are all the metals, as you go further this way, they become more reactive. And as you go further down, you get to the most reactive metal of them all, francium. So francium is the most reactive metal on the entire periodic table. Francium. The nonmetals are a little bit different because nonmetals react obviously with metals, but they react with both metals and nonmetals. And their reactivity goes in the other direction. The most reactive nonmetals are further to the right and up. So fluorine is the most reactive nonmetal. And as a matter of fact, I would say that fluorine is the most reactive element, period, because fluorine reacts with both metals and with nonmetals. And there is even some rare situations where fluorine can react with some, but not all, of the noble gases, which we're going to find out later is very, very strange. So fluorine, the most reactive nonmetal. Lastly, what are the chemical properties of noble gases? Well, that's kind of weird because their chemical property is really that they have no chemical property. They are unreactive. That's why they're called noble gases. They don't react. So these guys here are noble gases because they don't react with anything. But as I said before, there are some exceptions where fluorine can make them react, but not all of them. And that is our first lesson on parts of the periodic table